Okay, so here are a couple of examples of when we have inverse proportion. Now, as soon as you see the fact that you've got inversely proportional variables, what you need to do is remember that you need a 1 over in the proportionality statement. This is what it will look like. If L is inversely proportional to M, then I can say that L is proportional to the reciprocal of M, or 1 over M. Okay, so as soon as you see inversely proportional, this side here has to be a fraction. And as long as you see that word and you remember that that's what it means has to happen, you can then follow a process that's quite similar to the ones we've seen before. So if L is proportional to 1 over M, that means that L is equal to K over M. We then, as soon as we've got the form of the equation, put in the two values that we know. So we know that 11 equals K over 4. Times both sides by 4 to solve for k. 44 is our k value. So now that I know what k is, I can put it back into this form of the equation and say that L is equal to 44 over M. Okay, you could also write that as LM equals 44, or you could have M equals 44 over L. Any of those three are correct. Okay, so they're all fine ways of writing it. So now let's have a look at another one that's similar. Because we've got inversely, I know that I'm writing S is proportional to 1 over P. Therefore, S is equal to K over P. Okay, and now I put in the two values I've got, so I can say that 15 equals K over 3, times both sides by 3. So 45 is my K value. As soon as I've got my K value, I can put it into this form and say that S is equal to 45 over P, or SP equals 45, whichever way you prefer to write it. Okay, so here are two questions on inverse proportion. Again, I'm going to give you a couple of minutes and then I'll show you the answers, so just get as far as you can in that time. Okay then, so here are the solutions for them. Hopefully you were paying really close attention to that word inversely in those questions, because that's what differentiates these ones from the ones we've seen before. So first of all, if we have inverse proportion, that means when we set up our proportionality statement, we need to remember to pop a 1 over. Okay, so A is proportional to 1 over C. That means that we also have to be careful when we write our form of the equation. We need it to be equal to K over C. And from then on, it's a matter of just substituting in and finding K. So from then onwards, it becomes a little bit easier. So we're going to put the 12 and the 6 in. This time we need to times both sides to get k on its own. So we're multiplying both sides by 6. That's going to get us a k value of 72. And as soon as you've got your k value of 72, you can pop it back into that equation to get a equals 72 over c. You can have that written a slightly different way. If you multiplied both sides by c, you could write it as a times c is 72. And you would also be correct if you had written it as c equals 72 over a. All three of those are just different ways of rearranging the same relationship. So they are all correct and would all get you full marks as long as you had the full method shown nice and clearly. Here's the second one. So again, because we have the word inversely in the question, we know we need a 1 over in our proportionality statement. That leads us to having k over f in our equation. Put the two values in, the 2 and the 10. We're going to multiply both sides by 10 to find k as 20. And as soon as you've got k as 20, we're popping it back into the formula. And therefore we have d equals 20 over f. We can write that as df equals 20. And you could also have it as f equals 20 over d. Okay, so this is an Edexcel GCSE style question. You can approach this one of two ways. So have a little read through, do what you think you would do in an exam, and then I will talk you through the two methods in a moment or two. Okay, so the first method I'm going to talk you through is the formal algebraic process. We're going to create a formula, and once we have a formula, we're going to use it to find y when x equals 6. So, because y is inversely proportional to x, we say that y is directly proportional to 1 over x. That means that y is equal to k over x. If I then put in the pair of values that we've been given in the question, I can say that 36 equals k over 1.5. If I now multiply both sides by 1.5, I can get my k value as 54. And now that I know k, I can pop that back into the original formula, okay, and have the rule that y is equal to 54 divided by x. Now that I have a formula, I can just pop the x value that I know in and then solve to find out what y is. So when x equals to 6, y is 54 over 6, which comes out as 9. The other method you could have used is looking at the relationship between the two x values you've been given. So we know that x is 1.5 when y equals 36, and we need to find the other value of y when x equals 6. So looking at what we have to do to go from the first x value to the second, we need to multiply by 4. Because this is an inverse proportional relationship, we're going to need to do the inverse to y, or the opposite to the y. The opposite of timesing by 4 is dividing by 4. So if you do 36 divided by 4, we get our answer out as 9. This method is much quicker for this question, and you would get full marks for it in the exam as long as you made these values here and what you were doing very, very clear. The formal algebraic process, however, is something you do need to make sure you know, because you might get asked to find a formula. Okay, and for the more difficult questions that we're going to see in a minute, you will also need to be able to do the formula for. Okay, so this is the most difficult that this can come up. So what I've done is I've made a question that involves all of the different complexities all in one go. So one complexity is I've got the word inversely. Another complexity is I've got the square of instead of just b. So we've got a couple of things that we need to be aware of when we start out. So when we make that original proportionality statement, we've got a is inversely proportional, so it has to be proportional to 1 over. And then we've got the square of b instead of b. So because it's the square of b, we're thinking b squared. So underneath that fraction, I need to write b squared. Okay, so the inversely is what meant I had to put the fraction in, and the square of b is what meant I had to put that power in there as well. Now that I've got that made, I can start working through. Sorry, I can see the shadow there isn't helping you. Okay, so now I've got that, I can write a is equal to k over b squared. And from then on, it's very similar to what I've got before. I just have to be careful to make sure that this is what my formula looks like at the end and that it does have squaring in it as well. So I'm going to put the 7 and the 3 in. So 7 is equal to k over 3 squared, which is k over 9. If you're confident, you can put that in straight away, but if not, you can write the squaring in first. I've got to times both sides by 9, so you should get 63 out as the k value. Once you've got 63 as the k value, you've got everything you need for the form of the equation. So I can say that a is equal to 63 over b squared. Okay, and that is going to be the formula I can use. And if I then got given a value of a and asked to find a value of b or vice versa, I could use substitution to work that out. Okay, so here are two GCSE style questions on the topic of inverse proportion. The one on the left-hand side is slightly easier. The one on the right-hand side is slightly more difficult. So pick which one you want to have a go at to start off with. I'm going to leave you for 2 or 3 minutes to have a go at doing this. Try and show your full exam method if you can. And if you get them done in time, you might be able to have a look at the second one as well. Okay, so here are the solutions for these ones. So even if you didn't have a go at both of them, watch and try and follow the method to make sure you understand how you would get all the marks in an exam situation. So for the first one, we've been told that D is inversely proportional to C, so therefore D is proportional to 1 over C. That means that D is equal to some value K over C. We've been given a pair of values for C and D, so if we substitute both of them in together, we're now at the point where we're going to get our first mark for this question. You're then going to have to times both sides by 280 to get 7,000 as your K value. In terms of exam marks, you'll get the mark for writing this bit here in red, or if you just wrote that down. Okay, so either of those is fine. We now have enough information to get the full formula, Okay, so this bit here in red again would be your second mark. Okay, and then for the third and final mark, we need to actually answer the question, which is finding D when C is 350. So we're popping 350 in where C is, and then getting an answer out of 20 for our third mark for that question. For the second one, we're going to need to say, first of all, that y is proportional to 1 over x squared because of that word inversely. Then we can turn that into an equation, y is equal to k over x squared. Now we've been given our pair of values, y is 3 and x is 12, so we're going to put them in. And notice that I've been careful to square the 12 to get 144. Now that we're at that point, we've got our first mark, or you could get that first mark for getting k as 432 if you times both sides by 144. Now we have enough information to get the full formula, and that gets us our second mark. And at this point, we have enough information to solve the question. If I put x is 4 into that formula, I can show nice and clearly that y comes out as 27. Because this is a show that question, you have to make sure you're showing the process really nice and clearly. So every single line of that method is going to be important to guarantee you all the marks in that show that question.